Now we're on. There we go. Welcome back. It's time to do a giveaway. This giveaway, it's our first one, right? First giveaway. This is a throw to fly and wave to control mini drone. What happens if everybody waves at the same time? All right. Throw to fly and wave to control mini drone, and we have the bowl right here. If people haven't put their name in, can they do that somewhere after this for the next one? Okay, we're going to have several more drawings throughout the day, so there's still time to get your name added if you haven't already. And the first prize goes to Michael. How many Michaels are there out there? Last name Poove or R-E?
R-E.
Michael Poor.
Yay!
All right, here we go. Does it go back in the basket? Does he get a chance for that? No? Okay. All right, you're out.
But if you didn't register, the card's on the end of the table.
Okay.
In 1942, Ann Miller was the first patient to be treated with penicillin. But she was not the first person to whom penicillin was administered. The gentlemen who were developing penicillin wanted to test their drug, and so they found a terminally ill patient. It was another woman. We don't know her name, or at least as far as I've been able to tell, it was never recorded. But they tested the drug on her, found that it was indeed toxic, and had to go back to the drawing board and redo things. I wish we knew her name, because she is no less deserving of our thanks and our gratitude than the gentleman who developed penicillin. That was in the 20th century. Now we're in the 21st century, and things are a little bit different. Women in the 21st century typically don't wait around passively to be the subjects of experiment by men. Instead, in the 21st century, they go out and they start their own biotech companies. They don't even wait to be terminally ill. They take matters into their own hands, motivated by love for their children and by their communities and world. They take the risk and administer experimental therapies to themselves. There's always someone who takes that risk in every generation. The most important thing, though, is in the 21st century, we know their names. Please welcome Liz Parrish, CEO of Bioviva and Patient Zero.
It's great to be here. When Micah told me about the event, I was really excited to come here. I've actually spoken at a couple events with him in different places in the world, and I think he's a very articulate speaker. So, faith, that's a topic today, and that's a very interesting topic for me. I remember being in chemistry class and asking my teacher if he believed in God. And he said, well, of course I do, because humans work towards things that we'll never see in our lifetime. We take great risk to create a future that we may not achieve. And I think that that is a beautiful vision of faith. So in 2011, I was volunteering my time for the advocacy for the use of stem cells, autologous stem cells from your own body to treat illness. I spent 2 years doing that. I learned a lot about regenerative medicine. And during that time, I fell in love with genetics. And why did I fall in love with genetics while working with stem cells? Well, genetics are behind the technology that actually makes a stem cell regenerative. It's what gives it the ability to heal your body. So I spent 2 years doing this. I see a lot of faults with the system. I see that there's doctors working offshore, but no researchers working with them. I see that the research in the United States and Harvard and Stanford is going fantastically, but it's not translating to humans. And in 2013, something catastrophic in my life happens. My son is diagnosed with type 1 diabetes. It was very, very hard to face a disease that without science, without technology today, he would have died. When I asked around the hospital what sort of interventions that they had in regenerative medicine that actually could help him, they said, lady, essentially, that's experimental medicine. We don't use that in children. You should consider yourself lucky. There are kids here who are dying. Well, that didn't sit too well with me. I'm going to move this down a little bit. That didn't sit too well with me. I don't understand why we would let people die. They would lose their greatest asset because we're afraid to try something new. So this is a great quote from William Burroughs. Man is an artifact designed for space travel. He is not designed to remain in his present biologic state any more than a tadpole is designed to remain a tadpole. When you realize the frailty of the human body, you are opened up to a world of possibility through genetics. My company, Bioviva, was actually designed to translate experimental medicine to humans, to expedite the use of these technologies, to de-risk investment from investors, and to help biotech companies come up to par and to speed and become the next leaders of the biological revolution, usurping other companies who have basically not done well with the use of their time. Why do we look at biological aging when I was looking for cures for kids? Well, it turns out that all of the treatments that we look at for biological aging in regenerative medicine and gene therapy actually treat childhood disease. Every one of the genes of choice will treat the childhood disease. And if you're wondering if aging is a disease, you can just look at this chart. Aging starts, the diseases of aging start to hit us around 45, and they exponentially go up from there. As a matter of fact, a person over the age of 65 has 2 or more diseases of aging. Generally, they're just being treated for the shortest burning fuse. Looks like the whole graph isn't on there. And great thinkers have been thinking alike for a long time. It took my son to be diagnosed with type 1 diabetes for me to step into the world of even considering what would treating biological aging be like. I mean, I wasn't looking to extend human lifespan. I was looking to cure kids. But it turns out that if we find cures for kids, they only go on to live a couple more decades before they become ill with another disease. Robert Boyle in 1662 put on his wish list the recovery of youth. And Benjamin Franklin really actually felt that he was dealt a heavy blow by being born in the wrong time. That if he had just been born later, he might see these type of technologies come to pass. So what does my company do? What have we done since my son was diagnosed? Well, in 2011, again, I was volunteering for regenerative medicine. In 2013, my son was diagnosed with type 1 diabetes. In 2015, I launched Bioviva, by taking the first 2 gene therapies to treat biological aging in the world. Our targets are the hallmarks of aging. These are the 10 things that are happening at the cellular level that make you grow old and die of what are actually just symptoms of these processes. We call them things like dementia, cardiovascular disease, type 2 diabetes, and cancer. And the reason I put these 4 diseases up here is because these 4 diseases alone kill 80% of the population in every industrialized country. And by the year 2050, aging is the biggest killer in every country on the planet. Here we see some things that you might have heard about, like mitochondrial dysfunction and epigenetic changes. In cancer, we specifically see DNA mutations. It's the only disease that has this one outlier of the hallmarks of aging only to itself. Nutrient sensing is in type 2 diabetes, dementia, and cancer. And if we go up to cardiovascular disease, we see glycation, which it also shares with dementia and type 2. But most of these are actually all shared amongst every one of these diseases. And that's why when you have one disease of aging, you most likely have 2 or more. As a matter of fact, if we cured cancer today, your average lifespan would probably only go up by 2.5 years. So how are we going to affect this condition and actually change it significantly? And that will be through genetic modification. Here is a video, and this is what gene therapy looks like. So when we treat patients with gene therapy, we take a vector. We take out this vector's ability to do anything like get you sick or transmit any of its own genes, and we put inside it a therapeutic gene. My company specifically looks at genes that upregulate regeneration because aging is cellular degeneration over time. That's the most simple way to think of it. It's those 10 hallmarks degenerating over time. And if we can upregulate regeneration as fast as the degeneration happens, we can create a homeostasis. We can potentially even do better than that. I'm not going to give this talk today, but when we look at the genes from other species, we actually see regenerative capacities that can be used in humans that would actually regenerate us much faster than we're degenerating. And if that sounds really odd, in 2016, the genes from light-sensing algae were already used in human eyes in clinical trials. This is what it looks like to get a gene therapy. Essentially, it's an IV, unless you're having a specific organ treated, and then you're put under an anesthetic, and we do an image-guided delivery of the gene therapy. Does gene therapy work? This is 5 past gene therapies. These are completely through the regulatory service, and they're a one-time treatment for a lifetime cure. Gene therapy works. In the middle, you see severe combined immune deficiency. That's a long word for boy in the bubble disease. Those of us who are over 40 probably know what that disease is. It's a rare autoimmune disease, and the immune system is at such a deficiency that these kids can die of a common cold. With one treatment, they're now cured. The problem with these type of therapies that are coming through the regulatory service is the cost. People cannot afford this cost. Just most recently, spinal muscular atrophy now has a gene therapy cure. These children die within 6 weeks. The cure is $2 to $5 million. This is not the way to go forward. We cannot put a price tag like this on human health. This is just somewhere we need to not go. So what is my company doing to actually deal with this? We are trying to treat the world at scale. Aging is the biggest unmet medical need on the planet. Over 40 million people die every year of biological aging, just to put that into context. By scale, we can drive the cost of these gene therapies down significantly so everyone can afford them. Right now, Integrative Health Systems, our exclusive partner, is treating Alzheimer's disease with a telomerase-inducing gene therapy. They're doing follistatin for increased muscle for an aging population. Sarcopenia and frailty kill. It just killed my best friend's mother just a matter of weeks ago. It was tragic. Clotho for kidney regeneration and whole body rejuvenation with a myriad of these gene therapies in combination. We're really proud right now because Maximum Life Foundation, a nonprofit in the state of California, has actually sponsored a trial for 10 patients with Alzheimer's. So everything is 100% paid for except for travel and the pre and post testing, which is unprecedented for gene therapy. And this is very interesting. This is what an Alzheimer's brain looks like. A lot of people don't know that. You lose a lot of the folds in your brain with Alzheimer's. We use today 3 genes in the clinic through Integrative Health Systems, but we're going to talk about a 4th one as well. We're also going to talk about what hallmarks of aging that these gene therapies target. I took this gene therapy in 2015. I was the first person in the world to have taken this gene therapy into my body. Telomeres are the caps at the ends of your chromosomes, and with every cellular division, they actually get smaller, and, well, I should say shorter. And lifespan in about 50 different species now has been tied to the length of your telomeres. So when you're conceived as an embryo, you have about 15,000 base pairs. When you're born, you have 10,000. And by the time you're diagnosed with your life-ending disease, you have 5,000. Telomeres are critically short. We also find critically short telomeres in children with disease. One of the most notable diseases is progeria. It's accelerated aging, and the children usually die of cardiovascular events by the age of 15. This gene, this is actually the enzyme, but the gene itself codes for this enzyme, and it repairs the telomeres. It affects mitochondrial health, making them healthier. Those are the powerhouses of your cells. It improves genomic stability, so we think that it will protect against cancer. And it reduces senescence, which are old cells that build up in your body that no longer divide, and they send off inflammatory markers. A super note, it extends lifespan of model organisms, and actually this super double note at the bottom you're going to see at the end of every one of our genes of choice. Follistatin. This was the other gene therapy I took too. Follistatin increases your muscle mass. And this is a very cool gene therapy. It's been used in almost every acceptable animal model, including primates, and it increases their muscle mass. And it's gone through clinical trials for Duchenne's and Becker's muscular dystrophy. This boy here on the left has muscular dystrophy. He's having a very hard time getting up the stairs. Oh, sorry, I'm very moved by children. This is the same boy 3 months after treatment. So you can imagine what we can do with an aging population. Keeping people active, keeping them in the house with the stairs that they want to run up and down, keeping people in the workforce is really important. This gene therapy improves nutrient sensing, and a paper that came out just a couple weeks ago think that it also protects against cancer, which is quite amazing. And it actually extends model organism lifespan almost as much as telomerase induction. Enter the goddess Clotho. Clotho was named after the goddess of who spins the thread of life, and Clotho is actually a really amazing enzyme. It assists with brain function. So when they used it in model of mice with young, old, and Alzheimer's type models, within 4 hours they had a better cognitive response. But Clotho wasn't actually sorted out for looking at human intelligence. People with low levels of Clotho generally die younger of chronic kidney disease. So this is actually a protection against chronic kidney disease and cardiovascular disease. So we're really excited about this. It also significantly extends the lifespan of model organisms. But I've got to say, most people who contact us are actually interested in cognitive enhancement because we all want to be a little bit smarter. But we will be trying this in 2020 for patients on dialysis. And finally, PGC1 alpha. PGC1 alpha helps with biogenesis of your mitochondria, creating better quality mitochondria. It reduces white fat, so this would be a great treatment for obesity or type 2 diabetes that's associated with obesity. And it protects the liver against damage. It significantly extends the lifespan of model organisms. And this gene alone pretty much put to rest whether metabolism and lifespan was associated. When you look at organisms that have the same metabolic rate, like mice and bats, the bats can live up to 41 years, the mice only for a couple, and this gene seems to be the determining factor. Okay, so that's a lot. Those are your candidates. Those are your superhero genes, your superpower genes that we're looking at now. 3 of them are in use. The 4th one, PGC1 alpha, goes online at the end of 2020, hoping to try to significantly help patients recover and recuperate and live longer and healthier lives. So Bioviva actually has 3 arms of the company. That was the first arm. The second arm is research and development, and at research and development, we're working with Rutgers University. And we are working to create a bigger, better, more versatile vector delivery method. So today's delivery method is limited. We can put 1 gene in at a time, or like if you do a dual gene therapy like I did, we put them in at the same time, but they're 2 separate therapies. We want to be able to get therapies into 1 vector delivery, getting more predictable delivery into each cell of the genes that we're interested in, and essentially make it, simplify it for the patient, because treating biological aging will not be 1 treatment, it will not be 1 gene. But if we can get several genes into 1 vector, we may be able to actually deliver on that. So why would we do this? Well, this is how we historically do drug development. We look for a therapeutic interaction or intervention for each disease. And actually, in traditional drug development, we're looking for a therapeutic intervention for a symptom of a disease, not even just to target that disease itself. But if we treat aging, we can actually target all of these diseases at one time. These are our mice. These mice are not dead, they're asleep. I'm a vegetarian, and I said if we ever did an animal study, I did not want a bunch of sacrificed mice. I don't care if you like mice or not, I'm not looking to kill them. But these mice have been transduced with our new vector, and what they're showing there is a luciferase gene, which sounds very daunting, but it glows under imaging, and it can tell us where the gene therapy is actually getting to. So we're looking at 2 different modes of delivery, but these ones have been had it delivered directly to their torso. So we can see that it's actually working. And here you can see, I'll go quickly over this because this probably is not as much interest to you, but our mice that have taken the follistatin are heavier than the controls, and they're heavier than the other mice. And this is what we'd expect. They are gaining muscle mass. The gene therapy is working. And what is interesting is it's not just working when we directly inject it into their torso. It's actually working if we put it in their brain. So that means that it's doing what we expected, which is a systemic effect. The mice with the telomerase induction are actually a little bit lighter than the other aged mice, the controls, but the amazing thing is they're keeping their fur. Their fur is not falling out, they're not having thinning fur and the effects of aging. So that's really great. And so, you know, these mice are all 18 months, so they're considered to be the average age of somebody between 58 and 70 years old. So we started with old wild-type mice. So this is just a graph that again summarizes the weight gain in the follistatin mice, the muscle mass mice, and the lower weight consistency in the mice that are treated with telomerase. So what does Bioviva do in the U.S. Outside of research and development? Well, what we're doing is data science, and you can actually help us cure aging, and you don't even have to come forward to take a gene therapy. Today we have several people who are going through our arm of medical development. They're actually taking gene therapies. I'm no longer the only person in the world that's taken a dual gene therapy. And to the announcer's point, many of them are women. And that was really incredible because we are feeling empowered and we are putting ourselves forward to create a better world. And I just think that, you know, I'd like to put that out there, that we're really breaking the norm. So our healthcare database launches next month with our new website. It's called the Bioviva Vault, and it gives you a place to put multi-omics. And this looks really chaotic, but what are multi-omics? Multi-omics have to do with your environment, your genome, your microbiome, your physiome. It's your omics. And we can help you get omics up there if you've done Ancestry.com, if you've done 23andMe, if you've done MuBiome, if your medical records from your own doctor's office. You can share those with us so that we can actually expedite the cure for aging because you are the control. The rest of the database is full of our patients' data. So this is what it looks like. Here's how you would put in various data. And then on our side, we don't know who you are. Number one, I would not be looking into this. This is all bioinformaticians. They're qualified research scientists. But they don't have your, any particular information about you except for your health data. And it's not something where you're going to get a phone call and somebody's going to say, hey, Joe, we saw that you didn't throw in one of your health data analyses, hurry up. We are HIPAA compliant, we are GDPR compliant so that we can also get data from patients in Europe, and we are powered by Google, and then we are encrypted on top of that to ensure the utmost safety. So again, that's what we're doing. And then really quick, because I know that it is of interest, what the heck happened to me after I took the gene therapy? It's been 4 years now. I'll be 49 in January, and I'm feeling terrific. The great thing with gene therapy is we're not looking for any off-target effects. So when you take a small molecule, you're looking at a slew of side effects, and you're hoping that some of those side effects are actually going to control maybe your LDL cholesterol or various other markers in your body. You probably take a little bit of hit on your liver, and you take some hit to your kidneys. But with gene therapy, we're just upregulating a protein, the exact protein that you need, turning your cell into the drug factory for the regenerative protein that we're looking for. So what I saw, number one, I did both the telomerase induction and the myostatin inhibitor. We have seen consistent increase in my telomeres and my white blood cells. And this increase, again, you remember your telomeres shorten as you age, has been the increase associated with 33 years of increased telomere length. So in these tests, they do only test for the T lymphocytes. So this is only in my T lymphocytes. We saw increased muscle mass. So we would expect this, but the really cool thing about this is the image on the left is me before, and I used to do most of my meetings while running. I ran about 5 miles a day, and after treatment, I essentially was on plane after plane and going different places to try to talk to governments and officials about how we could regulate this technology in their countries. And I was not getting exercise, but we still saw the increase in muscle mass and the decrease of white fat. And so that is fantastic. Of course, with patients, we ask them to exercise and eat a healthy diet for maximum output. One of the doctors in our company also did the myostatin inhibitor, and he was actually playing some football at the time, and his muscle mass was much greater, but mine is a good indication of like an average person's lifestyle. We saw a reduction in triglyceride levels of 50%. We saw my blood glucose levels go down. We saw my A1Cs come down. So far, so good, and I'm feeling really great, and I feel so good that that's why last year we went ahead and launched this program to actually give people access. So I really love this quote: "The size of your dreams must always exceed your current capacity to achieve them. If your dreams do not scare you, they are not big enough." And with that, I'd like to say thank you.